Welcome to Pure Mathematics 1, Chapter 2, Co-ordinate Geometry, topic Drawing Curve. You can always plot a curve point by point if you know the equation. It means that when you have the equation, you take the value of x and you substitute in there to find the value of y, and you making them into a table and you have a lot of points, and then you plot them and you try to connect them as accurate as possible. After that, you'll get the shape of a curve. But often, or however, all you need is general ideas of the shape, and it will help you to reduce the amount of time you would have to spend on drawing a curve, because you know you need some particular point, and then you know the general shape of the curve, so you can plot really easy, and your sketch right now is quite sufficient enough to be understood. Begin with, now we go and find out the general shape of the equation y equal to x to the power n. So first of all, the graph of n equal to 1, which is y equal to x. The graph of this one is really simple. Here. It's very simple, y equal to x. So you find, because you know that y-x equals 0, y equals 0 too. So this line passes through the origins. And then you find another values of x. Here, the value of x may be 3. So you find that value of y is also 3. So you plot this point. You connect the origin with that point in order to get the line y equal to x. When n equals 2, n equals 2, you have y equal to x squared. Let me draw it here. Here's y. Here's x. And what y equal to x to the power 2 would be the parabola that we learned before. The parabola. You just need to know that when x equal to 0, y equal to 0 too. So that is a parabola that passes through the origins, and it faces this side because this one is positive. X squared always greater than or equal to 0. But when you have to face up with some kind of function y equals to minus x squared, you should notice that the graph now will face this side because it is negative. Now we'll look at the equation of the graph when n equals to 3. So we have the equation y equal to x to the power 3. Here's the general shape of the graph. Go from here to pass through the origin and go up here. When x increase, the coordinate of x increase, this one go from negative infinity to positive infinity, and it pass through the origin because when x equals to 0, y equals to 0 too. But you really need to care about the coefficients of the term which has the highest power. In this case, x equals to 3. So when y equals to minus x to the power 3, it reverses the graph. Will be something like this. So in this case, when x increase, this one goes from positive infinity to negative infinity because it flipped. Here we have a minus sign, we flip the shape of the graph. Next point, we have n equal to 4. So the equation of the graph is y equal to x to the power 4. In this case, it's really familiar with you guys because it's also a parabola. Because this one can be written in this form, y equal to x to the power 2 power 2. So in this case, this one would be the x, y equal to x squared in this kind of form. So it's also a parabola, but this one is much more steeper because this one is x to the power 4. If here is x to the power 2, here's x to the power 2, Here's x to the power 4. You also have to be careful that when minus x to the power 4, it will be something like this. Y equal to minus x to the power 4. Moving on, we will talk about a stationary point. And stationary point, just like name, it doesn't move at all. It's a point indicates where the graph changing from increasing to decreasing or vice versa. Like this one, I have a graph. I can draw it in any way I want. Like this maybe. Here this point indicate a point here. The graph increasing, but now it's decreasing. And the point that indicate that change will be called a stationary point. And here I can see that here's decreasing, right? But up here is increase. So this point will be another stationary point. And this one is also a stationary point. And here, let's talk about this shape. I have the equation y equal to x squared. And this one is my stationary point. The stationary point can be described as two terms. One is the maximum stationary point or is minimum stationary point. Here is a minimum stationary point because it indicates the change from decreasing to increasing. So this one is the lowest one, so it indicates the minimum point. But for this one, where the one indicates the change from increasing to decreasing, so this one is a maximum point. And here for this graph, increase to decrease, so it will be a maximum point. Now decrease to increase, so it will be a minimum point. Now we have, in general, we have a rule for the stationary point of a graph. The polynomial of order n. What is the phrase of order n mean? Here you can see that this equation has the highest term, which is x to the power 4. So the powers of the highest term will be the orders of the polynomial. So this graph, y equal to x to the power 4 minus x to the power 2, it is a polynomial of order 4. And for this case, powers of this one is 3, so this one is a polynomial of order 3. Hence, up to n minus 1 turning a stationary point. Now look at here, you see that this one has the order of 2, so it had one stationary point. But for this one, it had an order of 4, and here it has 3 stationary points. It said up to n minus 1 is maximum stationary point of that polynomial can have. Is a n minus 1 number, but it can be smaller. If it's 4, it can be 2 stationary point. If the graph would be something like that. I don't have an example here, but you can imagine that it's up to n minus 1. So it means that for the polynomials of order 4, it can be up to 3 and it can be 2 or 1. And now we will look at the intersection of the curve. Intersection of the curve and their x and y axis with x and y axis. Now I will illustrate it here. I have a random polynomial like 9x to the power 10 plus 5x to the power 4 plus 9x plus 5, y equal to 2. So when x equal to 0, here this one will be y will be equal to 5, equal to the constant term. We call this one the constant term. And here is a place where the graph will intersect with the y-axis. because when x change, the constant term is not affected by the value of x. So when x equal to 0, the equation will be the y will be the equal to the values of the constant term. So it's where the graph will intersect with the y-axis. And now I have an equation: x to the power 3 minus 3x squared plus x plus 3. So for this one, I have two. I want to draw the graph of this curve. So I factorize it into x minus 1 multiplied by x plus 1 multiplied by x plus 3. So the intersection between the curve and the x-axis will indicate the root of the curve. Here's I have this point, my 1, and here's my 3. I know the general shape. Of this one will be like this. Here. So the root of the equation will indicate the place where the graph intersect with the x-axis. Let me take another equation. I will have an equation we have the graph like this. Here. So the point where they intersect the place where the root of the equation lie on. And now we'll take a look at a special situation where I have my x and y axis here, x-axis. Here's my y-axis, and here I have a graph look like this one. Here, this point, the turning point of this curve lie on the x-axis, and this point may be 4, and this point here I want it to be 1. Because this one, you have to remember that when the curve touch the x-axis, so it has a 1 replicated root. So what is meant by 1 replicated root? The values 4 exist twice for the in the equation. So we have x minus 4 squared. This one, the values x equal to 4 exist twice, but it is the same, so we call it 1 replicated root. And for this value, we know that in order to get this value, one of the root of this curve must be x minus 1, and here the shape for the polynomial of order 3, because this one either the general shape for the polynomial of order 3. So we have this one to the power 2 and power 1. So the overall equation for this graph would be x minus 1 multiplied by x minus 4 squared. Now I will do some general rule for the shape of the curve. For the equation y equal to x to the power n, when n is a even number, even like 2 or 4 or 6 or 8 or ... etc. So both n, you see that here, this one is called an n, this one is called an n, this one is called an n. They are the tail of the graph. You can do something like this, and they both leave the graph on one side, up side or down side. Here, anything I want, but they have to leave the coordinate system in the same direction. This one is to the top and this one to the bottom. When n is an odd number, like 3 or 5 or 7 ... they leave the graph in opposite end. They would have a shape like this one. So if this one go from here, go to this point, so this one will have to go in the opposite direction. They have to go to the same direction. Or they can start here and curve in here, and then this one leave in here. So they have to leave the coordinate system in opposite direction. If the coefficient, this one, like a x to the power n, this one is positive, so it faces upward. And if this one is negative, a is negative, so the one face downward. This is negative, and this one is positive. Positive. If x increase, here's my x increase, they're going down, mean that they are negative. And when x increase, but they're going up, they are positive. Now we'll look at the curve of the equation in this form: y equal to 1 over x power n. When n, say odd numbers, like 1, 3, and 5, the shape of the curve will be this one here and this one here. They are called asymptote. This one go to infinity, and this one also go to infinity, and this one will never touch this line. There will be always a distance here, and this one, z line, will never touch each other's, and they are called asymptote of each other's. And for n is an even number, like 2 and 4 and 6 dot dot dot. We have the shape of the graph be something like this. Here and here. They are also called asymptote too, but for the even numbers. This one can be the shape of the 1 over x squared. This one can 1 over x, or 1 over x to the power 3. Just know the general shape of this kind of equation called asymptote. Asymptote.